Lesson 10.4, the Pythagorean Theorem. So this deals with, for us, with right triangles only. When you get into geometry, you'll see how it kind of can be used in other ways to tell you about triangles, whether they're right or not. So with a right triangle, you should know these terms. The two sides that come together to make the right angle are called legs. The side opposite the right angle is called hypotenuse. And here's really a very important thing you need to know about that. The longest side, the hypotenuse is the longest side, and that's going to be important in a few of the problems that you have to do, that you are aware that that side has to be bigger than the other two. And something that you will study more later, the 90-degree angle would be the biggest angle in the triangle. That's why it would be opposite the longest side. Okay, so there's a relationship between angles and sides. And like I said, you'll study more about that later. The Pythagorean Theorem, it was discovered by a mathematician called Pythagoras, and he studied a bunch of different things in right triangles, and he discovered this, that you take the two legs and you square their length, add it together, and it's the same as the hypotenuse length squared. So it's a squared plus b squared equals c squared. So what people mainly use this for is, if you know two sides of a right triangle, then you can figure out the third. So our first example right here, it looks like we have our two legs measurements, and this one is 24 meters. In case you can't read that, it might be kind of hard to see. And this one is 7 meters. We don't know C. So what I would like for you to do when you're doing these today is you're going to start off every problem today by writing this formula so you have it memorized for the quiz tomorrow. A squared plus b squared equals c squared. Write that down every time. The two legs are A and B, and quite honestly, it does not matter which one is A and which one is B. Those two are interchangeable. It's just important that you make the hypotenuse C every time. So I'm going to plug in the information that I know. 24 squared for A, 7 squared for B, and C squared. So you have to square the A and B. 24 squared is 576. 7 squared is 49, and that equals C squared. Well, in this particular problem, we're going to go ahead and add those two together because it says to add 576 and 49. That's 625. That equals C squared. We've already had problems where we had an equation, we had a variable squared, and we had to solve for that variable. What did we do to figure out what the C would be in this problem? It says C squared is 625. I know that that length isn't 625, but how can I find the actual value of C? What would we do to undo the squaring? What did we do recently in this chapter? Jessica? Square rooting. So that's why we talked about square roots, and that's why this is in this chapter. We would square root 625, and when you do that, you get 25. Okay, now, I do want to make sure I make this very clear. When we solved equations the other day where they were squared and you had to answer plus or minus when you were square rooting equations, this is one where you're not going to do that. Can anybody tell me why I can very confidently just say this is positive 25? Why is that? What's 25 supposed to represent in this problem?
C.
C, and which is A. What is C? What is C? It's the length of a side, right? It's the length of a side. So can a side length be negative? No. So this is one of those ones that I was talking about that you can very much say it's just positive 25. You don't say plus or minus on these. So actually on this one, since this was labeled meters, you'd say that C is 25 meters. C is 25 meters. All right. Let's look at this one. Anybody want to try to help do this one? I've got, it looks like A is missing. This one looks like 5 inches, and then of course the hypotenuse, I can read that pretty well, 13 inches. Okay, Stephen?
It would be A squared.
I'm going to write this first, Stephen. How about that? Okay, now go ahead.
It would be A squared plus 5 squared equals 13 squared.
All right. After you substitute the numbers in that you have, what should we do with those numbers, Stephen?
You should basically do the exponents.
Yeah, go ahead and square them. So what's 5 squared?
5 squared is, wouldn't that be 625?
Nope, 5 squared. 5 times 5.
No, 25.
25. And then 13 squared. 13 times 13. It's 169. Okay, once you know that, how can we get A squared alone, Stephen? Right, we're going to subtract 25 from each side. And A squared would equal 144. And to undo the squaring, this is where we're going to do what? What are we going to do, Stephen? Square root. And do you know what the square root of 144 is? What times itself gives us 144? It would be 12, and we would label that 12 inches. That one would be 12 inches. Okay, so notice that one, you don't add the two numbers. You got to make sure you do it in the right order. This time you would subtract to get the A squared alone, and then you square root. Anybody still writing the red? All right, let's go see. We're going to try another one. Who would like to try this one? Shane?
First do A squared plus B squared equals C squared.
Very good. Write the formula first, okay? Plug in the numbers.
A squared plus 6 squared equals C squared.
Good.
And the exponents would be 64 plus 36 equals C to the 7.
Good. 64 plus 36 is 100. And then our last step is going to be doing what? Undo the squaring. So,
square root of 100 is 10.
yep. So C would be 10, and you would label it inches. So the hypotenuse on that triangle is 10 inches. All right, we've got one more of these. This side is 15 meters. This side's 22 meters, and that's labeled B. I'm going to go ahead and write A squared plus B squared equals C squared. Somebody want to try this one? Tori?
It's 15 squared plus B squared equals 22 squared.
15 squared plus B squared equals 22 squared. And then square them. Do you know what 15 squared is?
225.
Right. 225 plus B squared. Do you know what 22 squared is? 484. Okay. And then how are you going to get B squared alone?
Subtract 225.
Subtract 225 from each side. And b squared is 259. And now what do you think we're going to do?
Get the square root.
Square root. Now this time it does not come out evenly, and that's okay. It comes out to this, Tori, 16.09, and we need to round to the nearest tenth. So what are we going to say? 16.1, and make sure you label it meters. If they give you a unit in the picture or in the triangle, you have to label it. If they don't, you don't have to. Okay, questions about that? We've got just a couple more things that we can use this on. This next problem, it's asking us if it is a right triangle, and it's just giving us measurements. There's no picture. What you're going to do is you're going to use the formula a squared plus b squared equals c squared. So it's really important you have that. 6, 7, and 10. Well, I don't have a picture. I don't know where they go, but we do have the information down that we need to be able to plug the numbers in, because we know the longest one is always going to be what? The biggest one's always going to be which letter?
Z.
Okay, so we don't know if this is going to work or not, but we know if I have the choice of 6, 7, and 10, 10 has to go in for C. And what we're doing really is we're testing this. So I'm going to put a question mark with an equal sign. We don't know if it's equal. I'm going to say 6 squared plus 7 squared, does it equal 10 squared? So if this is yes, it is equal, then yes, it's a right triangle. If it's no, it's not equal, then we're going to say no, it's not a right triangle. So we're kind of testing this in reverse. We don't know if it is or not. Okay, so 6 squared is 36. 7 squared is 49. And again, equal sign, I'm put a question mark. We're testing. Is it equal to 100? So anybody know what 36 plus 49 is? 85. So 85 I can now say is not equal to 100. So let's answer the question. Is it a right triangle? No. This is the work that you would show. If we came up with at the end 100 equals 100, then you'd say yes, it is. But in this case, it is not. Questions about that? Make sure you're always aware of which one's the longest side. Plug that one in for C. The other two, it doesn't really matter. All right, something that's a little different for us, we're going to find the distance between 2 points, and we're going to use the Pythagorean Theorem. We've had something in the past with 8th grade using the distance formula, and this is just a different way to do it. And I kind of like this better, maybe. So I see those points P1 and P2, and I need to figure out the distance between them. Okay, I didn't do a very good job of that. But here's what I can do. I can make that the hypotenuse of a right triangle by adding in 2 sides. I'm going to go here, and I'm going to go across here. You see how that would be a right triangle right here? A right angle? So this side is 1 unit. This side, 1, 2, 3, 4, 5 units. You see how I counted that? So what I'm going to do is I'm going to find out that side. What do you think I would label that side? A, B, or C?
C.
Yeah, that's C. So I'm going to go A squared plus B squared equals C squared. I'm going to put 1 in, 1 squared plus 5 squared equals C squared. 1 squared is 1, 5 squared, 25 equals C squared. Go ahead and add those. 26 equals C squared. And then always the last step on these today, square rooting 26. Not going to come out evenly, is it? So we're going to round. It came out to 5.09, and I'm going to make it 5.1. Okay, questions on that? I'm going to kind of give you a heads up. You're going to be given some word problems, and every one of them is somehow going to give you a rectangle or a square or something, and you're going to use Pythagorean theorem. I know there's one problem about a computer monitor, and it wants to know the diagonal. Well, if you get something like that, remember A, B, and C. Any of those would be like that.